Bismillahirrahmanirrahim. This is the second video of source-free parallel RLC circuit, and here primarily we'll be solving two problems. And if you recall from the previous video, we follow this solving strategy. So we'll follow the same strategy, these 5 points. And this is the question. Here the initial voltage and initial current is given. We have to find Vt for t greater than 0. So the first step, as you know, that we need to find V0 and I0 for t less than 0, which fortunately is given both here. So just write down those two values. So this is our step number 1. And in step number 2, we find dV dt through KCL. So let's write the current equation here, KCL. And you can see 3 currents: current through resistance, current through inductor, current through capacitor. So IRT through resistance, IT is through the inductor. We don't write IL because all currents through inductor are given name IT. And then ICT, current through the capacitor. And then we put t is equal to 0 to make all the t 0. And at t0, now this V becomes V0. So the current IR0 will be capital V0 divided by R. So just like here, capital V0 divided by R. This current through the inductor will be called I0. And this will be called C dV dt. We know the current through capacitor is C dV0 dt. And now we plug in the values. These are the values given, initial conditions. So V0 is 5, here 5, divided by resistance 6.25. Current is 0, so I'll write that. Capacitor value is given 10 millifarad and dV dt. And from here, by solving, you can find dV0 dt to be minus 80 volts per second. Now let's move on to the third step. In the third step, we try to find alpha and omega. We know the formula. For parallel, it is alpha is 1 over 2 RC. So putting the value of R and C, alpha comes to be equal to 8. And the omega is 1 over under root LC, and this is equal to 10. And now if you note that alpha is less than omega, so this is an underdamped case. And so for underdamped case, we have to select Vt, and we have 3 choices. From there, this is for the underdamped case. So we select this equation. So this is the equation for underdamped case, where Wd is given by this formula, omega naught square minus a square under root. So we plug in the value of omega naught and a, or alpha. So we get omega d or Wd is equal to 6. And now putting the value of alpha in the general equation and Wd, this is our general equation. Wd we have put in 6. And now the final stage is to get the values of A1 and A2. So this was the general equation that we had. And if you recall, to get values of A1 and A2, first of all we put t is equal to 0, and then we differentiate and put t is equal to 0. So let's put t is equal to 0 first. So at t is equal to 0, this will become V0, and this term, if you see this at t0, this will become 1, cos 0 will become 1, sin 0 will become 0. So this term will become 0. So only left is A1. So A1 is equal to V0. and V0 from the initial condition is 5. Therefore, a1 is equal to 5. So this is the first value we have got of the first equation. And now we differentiate Vt. So differentiating Vt with respect to t, and here again you can see there are two terms, or it's a product term. So this term and the term in the bracket. So by product term differentiation we get this answer. I hope you can do this. And now we put at t is equal to 0. So therefore on the left we will get dv0 dt, and here again all the sign terms will become 0. So from top we get minus 8a, cos 0 is 1, so minus 8a, and from here we get 6a2. And now we know the value of dv0 also. So it was minus 1 we had calculated earlier. So we plug in this value here, putting in and solving the 2, we find a1 to be 5 and a2 to be minus 6.667. Now we plug in the values of a1 and a2 into the general equation that we have to get the final answer. So our final answer is as shown here. Now let's do the practice problem. This is the practice problem. One important thing here is now, in this case the initial condition is V0 is 0, but current is given. So let's see how does this behave. Technique remains same. These are the strategies we will follow. So first of all, we know that this is the given condition, so we just write that for t less than 0, first one. Then we write the KCL equation, and from KCL we write in terms of voltage, and then we plug in the values. Now V0 is 0, so this term will become 0. I0 is 50 milliampere, so we write 50 milliampere, and capacitor is 25 milli. So from here dv dt 0 is minus 2. And now we find the third term here, alpha omega. So putting in the values, we get alpha to be 10 and omega also to be 10. Now from here I am sure you can quickly guess that since both are equal, alpha and omega are equal, therefore this is a critically damped condition, and so for critically damped condition we will select this equation. Okay, so this is the equation for critically damped case, and now we put alpha, the value of alpha 10, to get the general equation. Okay, so this was the equation that we got. Now we'll put alpha, value of alpha. So this is the general equation that we have. And now we need to find the unknowns a1 and a2. And if you again recall, we had to put t is equal to 0 in the first case to get one equation. So we put t is equal to 0. This becomes v0. And since this term is multiplied by t, therefore this will become 0, and e raised to the power minus t will become 1. So the only thing left is a1. So v0 is a1, and v0 we know is 0, therefore a1 is also equal to 0. And now we have to differentiate this to get the second equation. So by differentiating, again here you can see the two terms. So we are keeping we take this term and differentiate the other term, and in the second we keep the first term and differentiate the second term. So this is the equation that we get. Now we put t is equal to 0 in this also. So dv dt 0 is minus 10a, this becomes 0, and a2, and this is obviously 1. and so dv dt 0 is, now we put the value of dv0 that we had got earlier, minus 2. Therefore a2 is equal to minus 2. So now if you put in the value of a1 and a2 in the general equation, so a1 is 0 and a2 is minus 2. So our final answer will be like this. You may write ut with the answer, or you may not write. Ut is signifying that this equation is for t greater than 0. So I hope this gives you an understanding as to how to solve parallel RLC circuit problems with zero source. Thank you.